Hello. I'm often asked how the primary and secondary physical constants were derived at binary mechanics lab. The secondary physical constants are shown in the red box here below and are unexplained measurements, wrongly called fundamental constants. And these are used as input parameters in various theories, such as the standard model of particle physics, where there's some 20 or so values which are input parameters in order to make that theory work. That's very lame. General relativity uses the vacuum speed of light right there in the field equations. That's also very lame. It's sort of like you have to master arithmetic before you can do algebra. The vacuum speed of light, why it has the measured value that we observe, is like the arithmetic, and the algebra would be trying to explain phenomena such as the attraction of objects and gravity or what have you. Appendix A in almost any textbooks is called Fundamental Physics Constants, listing velocity of light, Planck's constant, electric charge, and so forth. And this is sold by obedient physicists as fundamental inputs required by incomplete, flawed physical theories. With multi-millions in research funding, the scientists appear very authoritative. However, the greatest body of unexplained observations in physics, think about that, the greatest body is the so-called fundamental constants. So Appendix A in your Physics 101 textbooks should say most important unexplained data in physics. News alert, Binary Mechanics Lab published first ever derivations of basic physical constants from first principles. Here are equations for the alpha coupling constant and the Bohr magneton, which express those values in terms of other so-called fundamental constants. The measured values of these so-called fundamental constants are not independent, as these equations show. They contain redundant information. If they didn't, you couldn't write these equations which you see right before your eyes now. Therefore, these constants are not fundamental, and furthermore, they could not be fundamental if you understand what a simple algebraic equation is in fact saying. We might use an analogy to a video game in our adventure to derive the primary and secondary physical constants. We start the game located here between the orange box and full quantization in the green box. This is our wasteland where for hundreds of years, even millennia, investigators have based their work on the assumption of continuous energy, space, and time. In recent centuries, the theory of continuous energy, space, and time included classical physics, special and general relativity, and outdated 20th century quantum mechanics. But this whole area of our game map has turned into sort of a wasteland where, for example, in the game Fallout 3, a weather report might be scattered mutilations with occasional dismemberment. So, what we need to do is to venture into the postulate of binary mechanics of full quantization of energy, space, and time. Now, we're going to have to dip into the unexplained measurements, wrongly called fundamental constants, to reverse engineer these secondary constants below to obtain primary constants above. Let's look at that. With the postulate of energy, space, time quantization, the next logical question is, what are the values for energy, length, and time? How do we determine the values for energy, space, or length, and time? Well, we're going to have to look at the measured values for the so-called fundamental constants shown in red boxes here in our physical constants derivation tree. We use certain guidelines to reverse engineer the unexplained measurements to discover the primary constant values. First, we use dimensional analysis. In the derivation tree, units of derived values must follow from the units of input values. For example, bit velocity has the units of length divided by time. Electron rest mass has the units of energy expressed in kilograms. Planck's constant, which comes from our elemental action A, contains an expression for energy, mass times velocity squared, and an expression for time, our primary time constant. In other words, the units for the Planck constant are joules second. Likewise, the units of elementary charge are energy length, or joules length. Second, we have theoretical constraints. Binary mechanics postulates imply specific limits and/or constraints on possible values. An easy one is the speed of light. If you look at the spot cube model of space in binary mechanics, a unit of energy cannot just move in any arbitrary direction. It can only move out of that spot cube through the 6 faces of the cube. In other words, there's only 6 directions it can go. And so for a unit of energy to move from some arbitrary point to another arbitrary point, it has to take sort of a little bit of a zigzag pattern, usually, to get to the destination point. So that's a constraint. So therefore, we actually have that bit velocity is actually pi times the speed of light. Another theoretical constraint is that the spatial model of the spot cube lattice of space shows that the electron contains 3 M-type quanta. And so therefore, to be consistent, the energy constant here must be 1/3 of the rest mass of the electron. Another guideline is that calculated values must agree with unexplained observed measurements. For each of these items in the red boxes here, there are published, measured, observed values. Prior to binary mechanics, it was not understood why these quantities had the particular measured values that were observed. However, with those measured values, and if the quantities for energy, length, and time are correct, we should be able to calculate what the measured observed values are, and that should all agree. And all of this was set up in spreadsheets to calculate the values to confirm that these quantities for energy in kilograms, length in meters, and time in seconds, in fact, according to the equations shown here, give you the observed measured values. That is a critical point. Lastly, basic formulas in Physics 101 textbooks were applied where applicable. For example, to calculate angular momentum, it is the sum of the angular momentum of the various energy quanta, which I call one states, as they revolve around in what we call the bit cycles for the electron and the proton. So I think we're doing pretty good in our venture into the wonderful land of full quantization in binary mechanics. And our character hasn't had to use any health packs or stim packs because we haven't taken any damage. And so let's proceed. We've reversed engineered the secondary constants below and to obtain primary constants above. And then with those primary constants, we can calculate the unexplained observed values. Let's look at this quest in a little bit of detail. A series of papers document this second quest. We can do a quick walkthrough of the papers published in the Journal of Binary Mechanics, which establish